All right, today we're going to look at lesson 5.5, solving equations by graphing. Now, a lot of this is going to look familiar to you once we start breaking down the process. You are going to be using Desmos, so make sure that you have your phones, make sure they're laying flat on your desk, and you're not doing anything but using Desmos on your phone. Keep in mind, if you can't get the app on your phone, you can go to desmos.com and use Desmos through the internet. So that is an option as well. All right, so let's look at the essential question. How can you use a system of linear equations? Now, we just tested yesterday over systems of linear equations, so we know that in a system there are two equations. So how can we use a system of linear equations to solve an equation with variables on both sides? Now, you're going to notice in this very first problem, and I'll come back to that in just a second. In this very first problem, we have one equation, and we only have one variable in the problem, but there's a variable on both sides. Now, your mindset is to just move the 2x, follow the don't call me after midnight, and solve for x. But they're asking us to solve the equation by graphing. So we've got to go through the steps on how to do that. So let's go back to these steps. Step number 1, you're going to set each expression equal to 0. Now remember, an expression is a math statement that doesn't have an equal sign. So if I'm looking at a problem, if I'm looking at an equation, it's made up of two expressions set equal to each other. So we're going to take the expression on the left, set it equal to y, take the expression on the right, set it equal to y, and then we have two equations. We're then going to plug those two equations into Desmos, and of course we're going to find at least 3 points on each line so that we can copy that onto graph paper and find the point of intersection. Now, when we find the point of intersection, remember we're finding an ordered pair. But here's what's going to be special about today's lesson. Once we find that point of intersection, our final answer is just going to be the x-coordinate. Because if you remember that problem I showed you just a second ago, there's only one variable in the problem, and it's an x. So once we find that point of intersection, our final answer is just going to be the x-coordinate of the point of intersection. Now, let's put this into practice, all right? Example number 1 says solve the equation by graphing. So you can see on the left side, we have an expression, and on the right side of the equal sign, we have an expression. And we're supposed to set each expression equal to y. So y equals 1/2 x minus 3, and y equals 2x. So we have two linear equations, and I want you to take those two linear equations and I want you to go plug them into Desmos, and then I want you to copy those graphs onto a coordinate plane. Okay? Copy them onto coordinate plane. Now let's look at the graph in Desmos. All right, again, your two equations were y equals 1/2 x minus 3 and y equals 2x. So if we want to find some points that we can copy onto our graph paper, I see a very obvious one right here at 0, 0. We've got another pretty obvious one at 1, 2 on this blue line. And we've got one here at -1, -2. So really, I only need you to come up with 3 points. And there's 3 right there. All right, and then you would draw your line through them. All right, and actually, instead of that third point, we could use this point of intersection. If you go left to -2 and down to 1, 2, 3, 4, right there is a great point. And you can use that point of intersection for your blue line and your red line. All right, another point for your red line, you have a point at 0, -3, so you could use that point. And of course, at 2, -2, there's a third point. It does not really matter to me what 3 points you use, as long as you use or have 3 points on each line. Also, don't forget, at the end of your lines, you need arrows. All right, these are lines, these are not parts of a line. So at the end of your lines, make sure you have your arrows. Now, the point of intersection. We talked about step number 3, finding that point of intersection. And right here, you can very easily see our red line and our blue line intersect at the ordered pair, -2, -4. So if we write down that point of intersection, -2, -4, we remember from what I said earlier, the only problem or the only variable in our original problem was the x variable. So when we're solving, we just need to solve for x. So in this problem, in this point of intersection, we see that our x coordinate is equal to -2. And so the answer to this equation is x equals -2. Now I want you to work letter B with your partner and see what you guys can come up with. Write the two equations, plug it into Desmos, and then copy it onto your graph paper. Now, hopefully writing these two equations were pretty simple. We do have -4 plus 9x on one side of the equal sign and -3x plus 2. Now we know that the equation of a line is best in the form y equals mx plus b. So when I write this first equation, I'm going to write y equals, I'm going to put the 9x first and the -4 second for my first equation. And then for my second equation, I'm going to do y equals -3x plus 2. Now hopefully you were easily able to plug those equations into Desmos and your graphs looked something like this. Now if we identify points that are on the graph, you probably notice that your point of intersection isn't quite as noticeable. So I've zoomed in here so you can see right here the point of intersection is actually at half, 1/2. Okay, so you go right to half, you go up to half, and that is where your point of intersection was. So really finding a couple more points might be a little bit more difficult for this one, but as long as you have your point of intersection, that's going to be huge, because remember, our point of intersection, which we've already discovered, is 1/2 and 1/2. Again, the original problem only has an x in it, so we're only trying to solve for x, so x equals 1/2. So we box in our final answer. So finding that point of intersection is key. Now again, on your graph, hopefully when you were in Desmos and you had it opened, you could find a few more points because you need 3 points on each line when you copy it onto your graph paper. But that point of intersection, remember, you can zoom that graph in as much as you need to till you can get to that actual point of intersection. But that's how you use a graph to solve an equation. All right, now absolute value problems. We haven't seen an absolute value problem in a while, but again, let's go look at one before we talk about the steps. All right, we've got the absolute value of 2x plus 2 equals the absolute value of x minus 2. And you'll notice here that I have two different graphs. All right, remember when we solved absolute value problems before, you wrote two equations and you solved those two equations for two different answers. So solving the equations by graphing actually gets a little bit more complicated. So let's go back and look at our steps. Equation number 1, for equation number 1, and really this could say system number 1. So let's do that. Let's cross out, or let's cross out the word equation and let's put system number 1, because we're writing two systems of equations. So cross out the word equations and let's change them to system. System 1 and system 2. All right, system 1 is super easy. We drop the absolute value bars and we do exactly what we just did. We set each expression equal to y. We plug those equations into Desmos, we copy the graph onto the graph paper, and we find the point of intersection. Again, when we find that point of intersection, if the only variable in the original problem is an x, then our final answer is going to be that x value. Now, system 2. System 2, remember each system has two equations. For system 2, we're going to drop the absolute value bars. We're going to set the left equation equal to y. So we're not doing anything different. We're going to set that left equation equal to y. We're going to change the sign of each term on the right and set that equal to y. Plug those two equations into Desmos, copy the graph on the graph paper, and find the point of intersection. Again, the point of intersection, we're only solving for one variable, so our final answer will be that x value. Now, let's try this on letter A. All right, like I said, the first system is simple. We take each side, we drop the absolute value bars, and we set the expressions equal to y. So 2x plus 2 and y equals x minus 2. So go ahead. Well, let's write the second set of equations, and then you can plug all 4 into Desmos at once. All right. For the second system, we're supposed to drop the absolute value bars on the left and set the problem equal to y. So y equals 2x plus 2. Now, hopefully you notice the first equation for each system is going to be exactly the same. Okay, exactly the same. Here's where it gets tricky. We are supposed to change the sign of the expression on the right and set that equal to y. So the second equation in the second system is going to read y equals, notice we have a positive x, so we're going to change it to a negative x, and we have a negative 2, so we're going to change it to a positive 2. And then we're going to plug those two equations into Desmos. So take those 4 equations, get Desmos, and plug them into Desmos. All right, the first 2 equations go on the first graph, the second 2 equations go on the second graph. I'm going to give you a minute to work that with your partner. Now, let's see what you got. Hopefully your lines look very similar to mine. Okay, we have the 2 equations. So we can easily see on the blue line we have a point of intersection up here at 2, 0. We've got a point right here at what would be negative 1, 0. And of course we like our point of intersection, which is down left at negative 4 and down to negative 5. There's a third point for the blue line. It can also be the first point of your green line. You've got 0, negative 2 is where the green line crosses the y-axis, and you can see that it crosses the x-axis at 2, 0. So very easily you should have been able to find 3 points for each of your lines. But we're going to focus on that point of intersection. That point of intersection. For this first system, the point of intersection is at negative 4, negative 6. I think I said negative 5 earlier, but it's at negative 4, negative 6. So if we write down that ordered pair, negative 4, negative 6, again, the only variable in the original problem that we're asked to solve for is x. So our first solution, or our first answer to this problem, is x equals negative 4. Now, the second set of lines. Let's see what you guys did on that. We've got our point of intersection at 0, 2. We've got a point at negative 2, 4 for the black line, and a point at 2, 0. So we can easily plot 3 points. The purple line, we have negative 1, 0, we've got a point, and at 1, 4 we have a point. So your points may vary a little bit, but those are some good points that you could have used. Now again, our focus is that point of intersection, and we know that our point of intersection is at the ordered pair 0, 2. So when we write down that point of intersection, again, original problem has an x, so we're solving for x. So our second solution, or our second answer to this problem, is x equals 0. And just like absolute value problems do, we have 2 separate answers. Now I want you to take a few minutes, and work letter B with your partner. Let's see what you guys can do together. All right, hopefully you started by writing your 2 equations. So for the first system, all we do is drop those absolute value bars and set the expressions equal to y. So y equals x minus 6, and y equals negative x plus 4. And there is your first system. For your second system, you drop the absolute value bars on the left and you set your equation equal, or your expression equal to y. So again, my first equation for each system should be exactly the same. For my second equation, I'm setting y equal to, I've got a negative x right here, so I'm supposed to change the sign to a positive x. I have a positive 4, I'm supposed to change it to a negative 4. And here is the second system that I'm supposed to plug into Desmos. So hopefully you plug them in separately, and your outcomes looked something like this. If we look at that first system, we've got some pretty obvious ordered pairs. We've got a point at 5, -1. We've got a point at 4, 0. We've got a point at 2, 2 on the blue line. On the red line, we've got the 5, -1. We've got the 6, 0. And we've got a 4, -2 also. So as long as you have 3 points on the line, it doesn't matter. And remember, back at the beginning, I told you when you do these lines on your graph, make sure the ends of your lines have arrows. All right, these are lines that you are graphing. So the point of intersection right here in the middle is at the ordered pair 5, -1. So we've got 5, -1. And we know the original problem only has us solving for x. So our first solution is x equals 5. Now, look at what happened for your second system. We've got a point at 4, 0. We've got a point at 2, -2. We've even got a point down here at 0, -4. The green line, we've got a point at 6, 0, at 4, -2, and at 2, -4. But what do you notice about these two lines? These two lines are parallel. They never touch each other. So for this system, there was no solution. So our final answer to this problem, there's only one. There's only one value for x, and it is x equals 5. So we're not going to box in no solution, because while there was no solution for that set, there was a solution for the first set or first system of equations. So our only answer is x equals 5. And we've seen that before as well. If I get two x values and I plug them in and one of them doesn't work, one of them is no longer an answer to our problem. So that's what has happened here. One of these systems gave us the answer x equals 5. The other one did not have an answer, and that's okay. And that is lesson 5.5. Remember, tonight for homework, you have your flipped classroom. You're going to be watching lesson 5.6. Okay, it's going to be more Desmos. So make sure when you sit down tonight to do your flipped classroom that you once again either have Desmos, the app, or Desmos.com, because you're going to want to use Desmos for graphing inequalities tonight for homework. All right, I will see you guys tomorrow.